Good morning. Uh, Today we are going to continue with the paper Mathematics N4, which was written in March-April 2025. So we are going to concentrate on question 5, which is concentrating on integral calculus. So we are going to start with question 5.1. So on question 5.1, they are saying integrate the following in terms of x. So we are going to integrate that with respect to x. So how are we going to answer that? This is question 5.1. 5.1, it's saying integrate is 3. Take note, this bracket is 3 over sec 4x minus 7 multiplied. It's 7 multiplied by 5 to the power 3 pi x plus a 9 divided by e to the power a negative 3x minus 3 pi over x. Let's go. Oh, before we arrive at minus 3 pi over x, we had forgotten another term. Take note, it's having plus pi plus pi multiplied by x to the power a negative 3 minus 3 pi over x. If we check how many terms are we having? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Then the sixth one is given as plus pi over 6 cosec squared pi x. We are doing that with respect to x. So take note, that is what we are required to integrate. So to integrate that, it therefore means you need to simplify this expression. So to simplify that expression, we go on to the first term. So if we are to check the first term here, there is our first term. We are having sec. We know sec theta will be equal to 1 over cos theta. So to convert that, it's saying 3 divided by sec 4x. That must be equal to 3 divided, we can write it this way. Then where there is sec, we are going to write it as 1 over cos 4x. Simplifying that is going to give us 3 multiplied by cos 4x divided by 1. So eventually, we are having 3 cos 4x. So here our answer, it means that one reduces to integral of, instead of writing this, so it means there we are now going to write it as 3 cos 4x. Then we just write the second term as it is, minus 7 multiplied by 5 to the power 3 pi x. Then it's now going to say plus, simplifying that, you have to take note that we have to take note, we have to simplify that. So let's simplify that third term. We are going to apply the laws of indices. So applying the laws of indices, you are having 9 over 3 to the power, not 3, it's e to the power a negative 3x. We have to change this one to be a numerator, so this becomes 9. The moment we put this denominator on the numerator, the sign changes, minus 3x. There. So it's fine there. So it means this. Take note, the moment we shift it on the numerator, this sign goes away. It was a negative, but the moment we shift it from the denominator to the numerator, this sign negative goes away. So that one, it means it becomes 9e to the power a positive 3x. So writing that, we are going to have plus 9, then e becomes to the power a positive 3x. Then this one, it goes as it is, plus pi multiplied by x to the power a negative 3 minus 3 pi over x plus pi over 6 cosec squared pi x, integral of that with respect to x. Now everything is in a format that we can differentiate. We are now going to start it's now in a format that we can integrate. We can now start the integration term by term. So the first one, here we are going to go to the formula sheet. If we go to the formula sheet, we are integrating cos. If we check according to the formula sheet, here the integral of cos with respect to x is going to give us that value there. So in other words, we are saying integrating the integral of cos x with respect to x is going to give us a sine x plus the arbitrary constant c. So if we are to check, it therefore means that if this term was integral of cos px with respect to x here, it will mean that this was going to change to integral of sine. The integral was going to be sine px divided by p plus our arbitrary constant. So applying that on our first term there, it will mean that this was going to be equal to 3. Then the integral there, of course, is gonna be sine 4x divided by 4. Then we go to the next question, to the next term. If you check the next term, there it's an exponent. We go to our formula sheet. If we check the integral there, here it is. Here it is on the formula. It's having k a to the power x. That is what we are going to use. So we are saying the integral of k we are saying the integral of k a to the power x with respect to x must give us k a to the power x all over natural logarithm of a plus the arbitrary constant c. This is what we got from the formula here. This is what we got from the formula there. Then using that, now when there's a coefficient there, now let's say if we are required to integrate k a to the power px there, meaning to say the x which is a power it's having, meaning to say the x there, our exponent, is having a coefficient which is not 1 with respect to x. It will mean that this will be equal to k a to the power px divided by p multiplied by ln a. So if we are to apply that here, it means here we are now going to have minus 7 multiplied by 5 to the power 3 pi x all over 3 pi ln 5. Then we go to the third term. If we check on our formula, there's nothing talking about e to the power. So if we go to our formula, there's nothing. That one you have to know that whenever we integrate, that one we are saying whenever we integrate e to the power x with respect to x, our final answer will be equal to e to the power x plus arbitrary constant. But now, take note, you can now be given e to the power px, which you need to integrate with respect to x. So it means that will become e to the power px divided by the p plus the arbitrary constant c. So it will therefore mean that here we are going to get here, it will mean it's going to be plus 9e to the power 3x divided by 3. And kindly take note, the 4 that we divided by here is the derivative of 4x. It will be more like we are having another term which is y is equal to 4x. So it's the derivative of this 4x. This is where this 4 is coming from, where we are saying divide by that. Then, if you check the next question, this part that we put here, this 3x here, is the derivative of this power. In other words, we are having something like y is equal to 3 pi x. So the derivative, the first derivative here, which is 3 pi, this is what we put there, and so on, and so on. Meaning to say, even when we go to the next term, the 3 that we put, we have differentiated here. Then we go to the next one here. That one we are going to apply. We are going to apply what's here. What's here? So here they are saying the integral. Let's create. Here they are saying the integral of ax to the power n with respect to x will be equal to ax to the power n plus 1 all over n plus 1 plus the arbitrary constant, which is, so it means here we are going to have plus pi, then x. If you check our power there, it was minus 3, so it becomes minus 3 plus 1, which is equal to minus 2 divided by a negative 2 there. Then we go to the next question. If you check the next question, you still go to the formula. Here it is given a over x. If you are integrating a over x, so here is the formula that we are going to apply. So it's saying the integral that formula is saying the integral of a over x with respect to x will be equal to a ln x plus the arbitrary constant c. So if we are to apply that here, it will mean that we are going to end up having minus 3 pi ln x. Then we go to the next one. If you check the next one here, we are just going to check on the formula sheet. If we check, they did not write specifically integral of cos squared, but we have to know that integration is the opposite of differentiation. When we integrated the cot here, when we differentiated the cot from the formula sheet here, this was our y. When we integrated the cot, here we got negative cos squared. So it means when we integrate negative cos squared, we must get cot. So it therefore means here, if we go back to the question, it implies that the integral, yeah, it implies that the integral of a negative cosec squared x must give, take note with respect to x, must give a cot x. Meaning to say, if we are to integrate a negative cosec squared kx here with respect to x, this must give us cot kx divided by k. So using that, it will imply that here, instead of reading it like this, we can write it as minus, then in bracket we put minus pi over 6 cosec squared pi x, so that we have this minus, which we know from the formula. So it will mean that integrating that, we are now going to have minus pi over 6. Then this part, when it's integrated, it's going to give us cot pi x divided by this pi. Then always remember, we'll eventually add an arbitrary constant after done with integration. So it means the answer to this will be equal to 3 over 4 sine 4x minus 7 multiplied by 5 to the power 3 pi x all over 3 pi ln 5. Then simplifying here, it's gonna be plus 3 e to the power 3x. Then here, let me check. Okay, it's fine. Then here, simplifying plus, so it's gonna be minus 1 over 2 pi x to the power a negative 2. But you have to take note here, if this term you can convert the power to be positive, it will mean that if you are to leave this power of x as positive, it will mean that it will go to the denominator. It will mean this term will be minus pi over 2x squared. Then going to the next term, it's gonna be minus 3 pi ln x Then the pi and the pi will cancel out, so we'll be left with minus 1 over 6 quot pi x plus the arbitrary constant. So this becomes the integral. Then we go to the next question. The next question, it was saying the impedance of a circuit is given by the equation, so that is 5.2. 5.2, let's write 5.2. So it's saying 5.2. They are saying V is equal to the integral from pi over 2 as our upper limit, 0 as our lower limit. Then in brackets we are having sine x minus cos x. We are integrating that. So they are saying the impedance of a circuit is given by the equation. This is the equation here. Then they are saying determine the value of V. So to determine the value of V, it simply means you have to solve here. How are we going to go about it? So it means we have to integrate that. So it means it's equal to the integral of sine. We just go to the formula sheet. Let's go to our formula sheet. If we check the integral of sine, it's giving us a negative cos x. So the integral of sine is giving us a negative cos x. So we just go integrating sine, we are going to get a negative cos x. Then we go minus the integral of cos. If you go here, the integral of cos, it's sine x. So it's minus sine x here, but it's having the limits, which is pi over 2 here, then 0 here. So substituting those two values, it means this will be given by negative cos x there. So it's gonna be pi over 2 minus sine pi over 2. We substitute upper limit, then subtract after, then we substitute the lower limit, minus cos 0. Lower limit is 0 minus sine 0. Then to simplify that, it simply means we are going to need the use of our calculator. We are simply going to need the use of our calculator there. So you have to take note. You take your calculator. Let's take our calculator now. Here it is. So taking our calculator, it therefore means we are going to substitute. Take our calculator. Taking our calculator, we are going to substitute that. So it's going to be open bracket. Always make sure that your calculator must be in radians. The calculator must be in radians. So take note, always make sure that your calculator, when dealing with calculus, the calculator is supposed to be in radians. So how are we going to put our calculator in radians here? Then angle unit 2 radian, we are going to is 2, so my angles are in radians. So I'm going to write the way I wrote it, open bracket, then we are having minus cos pi over 2. How am I going to write my pi here? Over 2 close minus sine pi over 2 minus sine pi over 2 it's minus sine, shift the pi over 2 close bracket, then I have to close for that one. Then I'm going to say minus open bracket, which is going to be minus cos 0 minus sine 0 this minus sine 0, this is going to give us a 0. So our answer here is 0. So what was the question asking? The question was just saying calculate the value of V, determine V. The impedance of a circuit is given by the equation, that one. Then they want you to determine the value of V. So here is the value of our V. Here it is. So our V is equal to 0. Then we go to the next question. Let's go to the next question. So to answer the next question, let's create some space here. Okay, it's fine. Let's just do it. Enter here. We are on question 5.3. So here it's going to be 5.3.1. The question is saying sketch and clearly indicate the area enclosed by the graph of y is equal to x squared minus 2x minus 3, and the x-axis also show the representative strip of the representative strip to be used to calculate the area. So first step, we need to sketch the graph. So to sketch the graph, what is it that we need? We are going to need the intercepts. So if you check, if we want the y-intercept, we are just going to substitute our x is equal to 0. So it means if we substitute x is equal to 0, we are going to have 0 squared minus 2 multiplied by 0 minus 3, which is giving us a negative 3. So the coordinates of the y-intercept will be given as 0, negative 3. Then take note, if you need the x-intercepts, we are going to substitute y equal to 0. So it means 0 will be equal to x squared minus 2x minus 3. It's now a quadratic equation, so we can solve using the quadratic formula. You can solve using completing the square. You can solve using factorization. So if you are to use factorization, it means this will be equal to x minus 3x plus 1. So each bracket is equal to 0, meaning to say x minus 3 is equal to 0, or x plus 1 is equal to 0. Therefore, our x is equal to 3, or our x is equal to, negative 1, meaning to say our x-intercepts we are having 3, 0, and negative 1, 0. With this information, we can sketch our graph, since it's not, we only mainly want to show the region that we want the area. But to sketch the graph, we might also need the turning point. So to get the x value at turning point, it means we are just going to substitute. We are going to find the x coordinate, the average of the two intercepts, which is 3 plus minus 1 all over 2, which is equal to 1. Then to get the y-intercept, we substitute the 1 in the equation. So it's 1 squared minus 2, 1 minus 3. Simplifying this, we are going to get our answer as minus 4, meaning to say the coordinates of turning point are turning point is going to be given by 1 minus 4. So using this information, we can now sketch our graph. So it means the sketch of our graph will be given like this. The sketch of our graph can be given like this. This is the x-intercept. This is the y-intercept. Then our sketch will be something like this. To sketch the graph, remember you need to know the shape of the graph. What tells us about the shape is the value of a. So from our function here, our a is positive, and we know if our a is positive, our graph will look like this, and if our a is negative, our graph will look like this. It's quadratic function. So here then we are going to mark. So we are having our x-intercept negative 1, positive 3. Here we found it to be negative 4. Y-intercept we found it to be negative 3. Turning point we found it to be 1, negative 4. But the question strictly says draw the graph here. It was strictly saying use the representative strip. Indicate the enclosed area which is enclosed by the graph and the x-axis. So the area enclosed by the graph and the x-axis is this one, which I'm going to shade in green. If you check, this is our graph and this is our x-axis. Here it's our origin. Here it's our origin. So the area enclosed is this part. The area between the graph and the x-axis. Then to draw the representative strip, it's just you just draw any part under this graph. It's just a small strip. So I can just show the representative strip is from here. Take note, it ends. It won't go beyond the graph. You can just show this as your representative strip. You just put any part under this shaded region here, because it's supposed to be just show a small width of dx, that is the small change, and a height of the graph. So you just take anywhere. So this could be your representative strip. Then you are done. And when you sketch a graph, don't forget to label your graph. Your graph is y is equal to x squared minus 3x. So it's minus 2x here, minus 2x minus 3. The equation that we were given in the question. We have to always make sure that we show the graph. We show the equation of the graph when we are done. Then the next question after that was saying That is 5.3.2. It was saying use integration. Using integration, determine the value of the enclosed area indicated. So it means to get the area enclosed there, we are going to get it as, so it's question 5.3.2. It means we are going to get integral of y dx. Our limits are going to be from -1 to 3. So simplifying that, we know why it's what. So this simply means this is the integral of x squared minus 2x minus 3 dx, with from -1 up to 3. Simplifying that, if we check, this is a polynomial, so it means we are going to be applying this formula, the formula which says, the formula that we are going to apply is the formula which says the integral of a x to the power n with respect to x will be equal to a x to the power n plus 1 or over n plus 1 plus the arbitrary constant. So if we are to apply that, remember here we are having limits, so we don't include the arbitrary constant. We only include arbitrary constant when we do not have the limits. So in this case, it means this is going to be x. When you add 1, it's going to be 3 over 3 minus 2. When you add 1, it's going to be x. It was to the power 1, so it will be 2 over 2 here minus, if you check here, it does not mean that there was no coefficient. The coefficient was there, but it means, sorry, the term in x was there. Does not mean it was not there. It was there, but it means it was x to the power 0. So it will mean minus 3, then x to the power 0 plus 1, 1 over 1. Then we have to know that we put our limits. Our limits is from 3 to -1. Then simplifying that is going to give, this is going to be the integral of this is going to be equal to, if you check, it reduces to x cubed over 3. 2 and 2 are cancelling out, minus x squared minus 3x. Our limits 3 and -1. So this it now means we are going to substitute our upper limit first. It's gonna be 3 cubed over 3 minus 3 squared minus 3 multiplied by 3 minus, we substitute the lower limit. It's gonna be -1 cubed over 3 minus -1 squared minus 3 multiplied by -1. Then we simplify. This is going to give us, so it therefore means we have to go back to our calculator. So that is going to give us, so it's going to be open bracket 3 cubed is supposed to be a fraction, three cubed over 3 minus 3 squared minus 3 multiplied by 3 minus and bracket. So we are going to have another fraction. It becomes negative 1 cubed over 3 minus a negative 1 squared minus 3 multiplied by a negative 1. This is going to give us a negative 32. It's going to be a negative 32 over 3. So you have to take note there. This negative, it's simply telling us that the area is below the x-axis. So when we are writing the area, it therefore means our answer is going to be given as a positive. So the required area will be equal to 32 over 3 square units, or you just convert that, it becomes 10 and 2 over 3 square units, or you write it to 3 decimal places as required by the question, so it becomes 10.667 square units. Because these 3 decimal places, you are told if answers cannot be exact, they can be rounded to 3 decimal places. So, and this question did not give you the degree of accuracy which it wants the question to be given. And then let's go to the last question, question 5.4. So let's create space here. We are going to remove this part only. So to answer 5.4, we are going to create that's for our 5.4. And the question is saying, evaluate. It's want you to simplify the integral of 3x cubed minus 81 all over 2x minus 6 with respect to x. So, 5 marks for simplifying that. So take note, to simplify that, so step number 1, we are going to factorize both the numerator and the denominator. So this will be equal to the integral. Our numerator becomes 3. Then we are now left with x cubed minus 27 all over the denominator. Common factor is 2. You are left with x minus 3 dx. But take note now on the numerator. On the numerator, we now have another term there, which is x cubed minus 27. If you check, this one can be written as x cubed minus 3 cubed. So this is difference of 2 cubes. And we know difference of 2 cubes, we have a formula. If you are having a cubed minus b cubed, this becomes, when you factorize, you end up having a minus b, then a squared plus ab plus b squared. So if we are to apply that here, it will therefore mean that for this term here that we put there, it will mean we are going to have x minus 3, then the other bracket gonna be x squared plus 3 times x, which is a times b, plus 3x plus this last term, which is 3 squared, which gives us 9. So simplifying that, it means we can factorize here our numerator further. So it means this can be done by saying the integral, these coefficients, we can factor it out to have 3 over 2. Then it becomes integral of, so our numerator there, it's now gonna be the 3, we took it out there. So it's going to be x minus 3. Then we have x squared plus 3x plus 9 all over x minus 3. The 3 there has been taken out already. So this one, when you simplify that, don't forget the dx. This part, if we are to check, this part on the numerator is the same as this part on the denominator. So they divide each other. So it means here we are now left with 3 over 2 integral of, what's that? It's gonna be x squared plus 3x plus 9 dx. So to integrate this, we are now to apply the theorem, which is saying the integral of ax to the power n with respect to x will be equal to ax to the power n plus 1 all over n plus 1. Therefore, it means we are going to be left with here 3 over 2. The first term there is gonna be x cubed over 3, then plus, here it's gonna be 3x squared over 2. Here it's going to be plus 9x. We add the arbitrary constant. Then from there, we are now going to simplify. So if we multiply, if we bring this here, 3 over 2 times this, it means we are going to be left with the half x cubed there, because the 3 and the 3 cancel out. Then if we multiply the two, those, we are going to have plus 9 over 4 x squared. Then if we bring this, it's gonna be plus 27 over 2x plus our arbitrary constant. This becomes our solution. Thank you very much.